Okay, welcome to our second part of the matter vocabulary. We're going to be looking at a few other things that are matter, and this is anything that has mass and volume. They're made up of atoms. A colloid is something we have mentioned before, and this illustration right here gives you pretty much what it is. This is a homogeneous mixture, but unlike a solution where the particles are small, these particles are larger, and this makes a big difference when you shine a light through them. You will see the light go through the material, which you would not do in a solution. So here they're adding something to this solution here, stirring it up, and as they do, now you can see the laser beam going through the material because the particles are reflecting it. Here they're adding increasing amounts of that stuff. It's a substance that will allow you to see a light go through it, but it will not settle out. The mixture will not settle to the bottom. That would be a suspension. A suspension, the particles are even bigger than they are in a colloid, to the point where if you leave it alone, larger particles will settle to the bottom, and what had been a homogeneous solution will now be very heterogeneous. Here we see sand particles in water. And when you first shake them up, it just looks all pretty much one color, but after a little bit, the sand settles to the bottom, and that's when you know you have a suspension. An element is the simplest thing that a substance can be. It can't be made any simpler. It's a pure substance to the point where all of the atoms in this are the same atom. They have identical numbers of protons in their nucleus, which makes them more or less identical to each other. There are 92 elements on the periodic table, and we'll be learning a lot more about them as we continue in chemistry. In a compound, we take two or more atoms and have them bound to each other, chemically bonded together. Something like water, H2O. One of the things that makes them different from a mixture is that in a mixture, the different parts are not bonded together. They're just mixing, moving around each other. But in a compound, they are, which gives them a definite formula. H2O means I have 2 hydrogens to 1 oxygen, that ratio. We'll see that a lot of this is due to the electrons that are in material. But we will spend a lot of time on compounds and why they form and why some atoms will join to each other and some atoms won't. Now, I said that a chemical compound has a chemical formula, and this is what a chemical formula is. H2O would be an example. It's a notation used by scientists to show the number of atoms that are in a molecule. We use the atomic symbols. For example, hydrogen and oxygen, we use H and O. And the 2 on the bottom of the H in H2O is telling us that there are 2 hydrogens. The fact that there's no number after oxygen means that it's 1. So this is a 2-to-1 ratio. That is the formula for water, 2 hydrogens to 1 oxygen. The most common kind of element are metals. They take up most of the periodic table. They are elements that have a shiny luster. They conduct both electricity and heat very well. They are malleable, which means they can be flattened out and put into different shapes. And they are ductile, which means they can be stretched out into wires. There's a lot of metals that you're familiar with: iron, aluminum, gold, silver, but there's probably a lot that you've never heard of before. They're rarer, but they're also there. The luster is the shininess that metals have, usually with a silverish color, but there are exceptions like gold and copper. And that's one of the easy ways to tell if you're dealing with a metal. This ability to be stretched out to wire has proven very useful because metal is stronger than ropes and things. And the malleability allows us to make all kinds of instruments that we would not have been able to make just from stone, as well as objects of great beauty, like King Tut's head here. Non-metals are basically everything that metals are not. They are not shiny. They're dull looking. They cannot be hammered into shape. They're brittle and break. They don't conduct electricity or heat very well. They don't make up very much of the periodic table, but a number of very important non-metals exist, such as oxygen, which is absolutely critical for life. We will see later on that one of the differences is that metals give away electrons and non-metals accept electrons. Metalloids are a strange little group that's right between the metals and the nonmetals on the periodic table. And no surprise, they have properties of both. They often, like this piece of silicon here, look very metallic, but they don't act very metallic. In terms of electrical conductivity, they're somewhere in between. And this actually makes them useful as semiconductors in the computer business. I've mentioned conductivity a few times now. Conductivity deals with the ability of a substance to conduct an electric charge. Metals are good conductors, nonmetals are very poor ones. This chart here shows different conductivity levels of different substances. Some of the nonmetals have zero conductivity. Silver turns out to be the best of all the metals. So when we're looking here at the most conductive elements, we see silver, copper, gold, aluminum. This is probably why, if you want to spend a lot of money, you go for silver or copper wires. Copper might be a little bit better because silver does tend to tarnish, but also the price of silver and gold makes them prohibitive for a lot of for how wiring your house. But copper does an excellent job. Some of these others, like sodium, would not be useful because they're just not metals you want to deal with. They tend to blow up when they get wet. Which brings us to reactivity, how reactive things are. If we look at just the metals, potassium and sodium are two of the most reactive metals that there are. These things blow up in water. Gold, on the other hand, is barely reactive at all. Now, what reactivity is the rate at which a chemical substance will undergo a chemical reaction. You can see here that iron is quite reactive. Unfortunately, it reacts with the air and the water and becomes iron oxide, what we know as rust. A gold car would be far less likely to tarnish or get rusted because gold just doesn't react. Sometimes you want reactivity. I mean, that's what makes chemistry happen. And things like, are these nitrile gloves good to work with acid? No, I don't think so. They catch on fire and acid. Good to know. This is where all the fun in chemistry comes in, making elephant toothpaste and just blowing things up, watching acids tarnish metals. But of course, it also means this is why you have to be very, very careful when you're messing around with chemicals. Don't mess around with chemicals. Don't mix them unless you know what you're doing. Thank you, and we'll talk some more tomorrow.